So if you look at page 54, we're going to talk about Dalton's law of partial pressures. Remember that pressure comes from gas particles that hit the wall or collide with the wall of the container. In a mixture, each type of gas will hit the walls of the container at its own rate, which means each gas will have its own pressure associated with it. We call this the partial pressure of the gas. Since each gas exerts its own pressure, the total pressure, which we abbreviate P total, the total pressure on the container comes from all the individual pressures, P1 for the pressure of gas 1, P2 for the pressure of gas 2, P3, etc., so on. The total pressure comes from the individual partial pressures of each gas added together. So P total, your total pressure, is the pressure of your first gas plus the pressure of your second gas plus the pressure of your third gas, and you just keep going for every gas in the mixture. Okay, think of it as like your tires in your car. Let's think about tire pressure. Okay, in your tire, you have a lot of different gases in a tire. There's, it's air, right? Your tire's air, so there's oxygen gas, but there's also other gases that are in air, like nitrogen gas. It's actually a lot more nitrogen than oxygen. So that's kind of beside the point. You've got also like carbon dioxide in there, and lots of other ones besides that. So each one of those gases is hitting the walls with its own certain rate. So the oxygen has its own rate that it hits the walls. The nitrogen has its own rate that it hits the walls. And that means oxygen's exerting some amount of pressure from just oxygen hitting the walls, and there's more different pressure from just nitrogen hitting the walls. And then there's even more different pressure from carbon dioxide hitting the walls. So for every gas you have in there, that gas's particles are hitting the walls at their own rate, causing pressure at their own rate. So if you want to know the total pressure, you have to know how much they all add up to. So here's a hint. If you see the words partial pressure or mixture in the problem, that means you are going to be using Dalton's law of partial pressures, which is this equation. Okay, so let's look at an example. A container holds a mixture of helium, neon, argon, and xenon gases. Mixture, that's our key word. Right there, I know that I'm going to be using this equation. P total equals P1 plus P2 plus P3, and we need to know how many of these P's to use. It says keep going for every gas in the mixture. So let's look. How many gases are in the mixture? Helium, that's 1. Neon, that's 2. Argon, that's 3. Xenon, that's 4. Since there are 4 gases in the mixture, I need to make this equation go out to P4. I need as many P's here as there are gases in the mixture. So since this mixture has 4 gases, I need this to go to P4. If there were only 2 gases, I would only go to P2. You're going to go to the same number of pressure as there are number of gases in the mixture. It says the partial pressure of the helium is 1.1 atm, the partial pressure of the neon is 0.87, partial pressures of the argon and xenon are 1.5 and 0.6 respectively. Respectively means in the same order, by the way. So it's saying argon and xenon 1.5 and 0.6, argon is 1.5, xenon is 0.6. That's what respectively means. And they're asking what is the total pressure of the container. So let's look at some guess boxes. If you flip the page, there are some guess boxes. I'm going to label this guess box number 1. Okay, we can even go ahead and number all of these while we're here. Okay. when we saw the word mixture, that told us right away we were going to need this equation. So I'm going to go ahead right now and put, yeah, my equation is Dalton's law. P total equals P1 plus P2 plus P3 plus P4. The word mixture told me that was the equation I was going to need. And I knew I needed 4 P's because when I read the problem, there were 4 gases. Okay, it says the partial pressure of the helium is 1.1 atm, so I'm going to call that my P1 is 1.1 atm. Okay, P2, they say the partial pressure of neon is 0.87. So P2, I'm going to make that 0.87 atm. Then it also gave me P3 and P4. It said that argon is 1.5 and xenon is 0.6. Both of those are also atm. And then it asked, what is the total pressure? So we are looking for, our unknown is P total. Now we need to make sure we have units for P total. If all these other pressures were atm, guess what? Your total should also be atm. And if your unknown is atm, that means your answer is also going to need to be atmospheres, atm. Now all we have to do is plug it in. We don't know what P total is, but we know that it equals P1, 1.1, plus P2, 0.87, plus P3, 1.5, plus P4, 0.6. Guess what? All we have to do is add these together. 1.1 plus 0.87 plus 1.5 plus 0.6, and I get 4.07 atm. Easy. Okay, let's look at number 2. A sample of carbon dioxide gas and water vapor is collected at 35 degrees Celsius. The container that the CO2 is collected into has a total pressure of 832 mmHg. At 35 degrees Celsius, the vapor pressure of water is 42.2 mmHg. What is the partial pressure of CO2? Whoa, hold on. Partial pressure, that's one of our key words. Partial pressure tells me I'm going to need this equation, P total equals P1 plus P2 plus P3, so on and so forth. Let's make sure how many P's we need here. We need to know how many gases there are. It says a sample of carbon dioxide gas, that's 1, and water vapor, that's 2, is collected at 35 degrees Celsius. Let's see, reading. There's no other gases. It's just carbon dioxide and water vapor. So since there's only 2 gases, we actually only need the equation to go this far. P1 plus P2. So when I come over to my guess boxes, I know right away they said partial pressure. That means I'm going to use this equation. There were only 2 gases, so I'm going to keep it at P1 plus P2. You'll also notice this equation has only pressures in it, but the problem was giving us all these temperatures. We don't need these temperatures, 35 degrees Celsius. We don't need those temperatures. There's no T anywhere to plug in into the equation. Those temperatures are distractors. You don't need those. It's just trying to distract you. All you need to know is that the total pressure is 832 and the vapor pressure of water is 42.2 mmHg. Those are our givens. P total equals, and P1 equals, it was 832 and 42.2. So if we have these numbers of mmHg, millimeters of mercury, those are our givens. We need to figure out what it's asking for, what are our unknowns. So we go back, we read the problem. It asks what is the partial pressure of the CO2. So partial pressure, that's the P1, P2, P3, those are all partial pressures. So we already assigned a number to P1. If they want to know a partial pressure, then they're asking us to find P2. So we're going to write P2 equals question mark. We got to have units here. You have to label it with units. So if P total and P1 are both mmHg, millimeters of mercury, that means P2 has to also be mmHg, millimeters of mercury. And that means my answer has to be mmHg, millimeters of mercury. From here we get to just plug stuff in. We know the total is 832. We know P1 is 42.2 plus P2. How are we going to solve for P2 here? All you got to do is subtract. 832 equals 42.2 plus P2. That means that 832 minus 42.2 will equal P2. All we have to do is subtract here. And yeah, you can even use your calculator. No one's asking you to do it by hand. Okay, there are two other problems on this page for you to try. Number 4 is a challenge problem, just for funsies. Okay, and go ahead, take a shot.